Hi viewers, you're welcome to today's lesson. This is a question on dimension analysis, and this is how WAEC bring their questions when it comes to the topic dimension analysis. We are done the simple way of finding dimensions of quantities like pressure, force, acceleration. Now we have this question, the power P of wind moving at the speed V used to turn a turbine of radius r is given by P is equals to K rho raised to power A R raised to power B V raised to power C. Rho here means density. Rho is the symbol for noting density. We have where K is the dimensionless constant, is a constant, so it doesn't have dimension. And we have the power P, is the dimensionless constant, and rho is the density of air. Determine the value of A, B, and C using the method of dimension. So how do we solve this question? We have the solution given on the board, but I'll clean the solution and solve again so that we can all see. So let's start. Firstly, you bring out the equation P is equals to K rho raised to power A R raised to power B V raised to power C. And the next thing, substitute the dimension of the quantities for the quantities. So instead of writing the dimension, instead of writing the quantities P, rho, radius, V for velocity, rho for density, we are going to write their dimensions. So the dimension of power is, we know power is work done over time, and the work itself is force multiplied by distance or displacement, and we have over time. Therefore, we can say the dimension of force is m L T minus 1 multiplied by L divided by time, and this will give us m L squared. This should be minus 2, not minus 1. T minus 2 over T, and finally we are supposed to have mL squared T minus 3. Using the knowledge of indices, you can solve this. So we have the dimension of power to be m L squared T raised to power minus 3, which is equals to, we have been told in the question that K has no dimension. So we can actually write the K there as K, or remove it while solving. So I prefer to remove it so that I won't have any problem while solving. But at the back of my mind, I know K is going to be in my formula when I'm done solving. So rho is the next one, which is density. Now our density is mass over volume. So mass has a dimension of m, volume has a dimension of L cubed. So dimension of density will be m raised to power m L raised to power minus 3. So we have m L raised to power minus 3. I want to ensure my writing is mL raised to power minus 3. Everything raised to power A. We were told R is radius. The dimension for radius is L, radius the length. And lastly, we have V, which is velocity, or sorry, V, which is speed. So the dimension for speed is raised to power -1, everything raised to power C. So the next thing we want to do here is break all these brackets. So we have m L squared T raised to power -3 is equals to m raised to power A, L raised to power -3A, L raised to power B that we have here, and break these brackets, L raised to power C, T raised to power -C. So I can rearrange, since there's no need for me to even rearrange, everything has been arranged. And next thing I'll just check is using the law of indices. Let me write, I have 3 L here, L. So I'll write only one L. Since they are multiplying each other, I'll just add the powers together. So I'll have something looking like this: m L raised to power 2 T raised to power -3 is equals to m raised to power A. So write one L and add the power of all the L together. 3A plus B plus C, and the next thing T raised to power -C. So at this point, I'll equate the powers. You can see m has a power of 1 here, and at this side it has a power of A. L has a power of 2 here, and this side it has a power of 3 -3A plus B plus C. T has a power of -3 here, while T has a power of -C here. So at this point I'll equate the powers. Equate the powers of each quantity or each dimension. So let's equate the powers of each dimension. I said the power of m here is 1. Anything raised to power 1 is that thing. So we have m raised to power 1 here, which will still give us our m. So for m, that means 1 is equals to, this 1 is equals to A. For L, we have L here has a power of 2, therefore 2 is equals to -3A plus B plus C. -3A plus B plus C. And lastly, I have T, dimension for time. -3 is equals to -C. I can decide to name this equation 1, name this equation 2, name this equation 3. So after naming, these are the names: equation 1, equation 2. Obviously from equation 1, A is already equals to 1. So we found the value of A already. From equation 3, we have -3 is equals to -C. Divide both sides by -1, and we're going to have C is equals to 3. So we cancel this. We have A to be 1, C to be 3. Then we can put the values of A and C into equation 2 and get the value of B. So put the values of A and C into equation 2. So we'll have 2 is equals to equation 2 itself is 2 is equals to 3 minus 3a plus b plus c. So instead of writing a and c here, we are going to put 1 and 3. So 2 is equals to minus 3 a 1 plus b plus, instead of writing c, then you write 3. And at this point we have 2 is equals to minus 3 plus b plus 3. So minus 3 will definitely cancel plus 3 out, because minus 3 plus 3 is 0. So 2 is equals to b is equals to 2. So at this point we have found the values of a, b, and c. Therefore, a is equals to 1, b is equals to 2, c is equals to 3. That means our equation p is equals to k rho raised to power 1. So mathematically we won't try the 1 here, just leave it. And r is equals to raised to power 2 and v raised to power 3. You can see at this point we have found the values of a, b, and c, and this is how the equation will look like. Thank you very much for watching the video. Subscribe to the channel, like this video. You'll see more solutions to questions like this. Thank you.